In 1977, a one-ton robot left Earth riding a slingshot of planets and never looked back. It was a time of bold ambition, a rare cosmic alignment that allowed for a grand tour of the outer solar system. We built two of them, Voyager 1 and 2, twin emissaries designed to explore the gas giants and then, if they survived, to drift into the void. Voyager 1 executed its mission flawlessly. It flew past Jupiter, revealing volcanic moons and a storm larger than our planet. It grazed Saturn, threading the needle through its majestic rings. Then, its primary mission complete, it kept going. Today it's the most distant human-made object, a silent testament to our curiosity, sailing beyond the sun's protective bubble into true interstellar space. For decades, it traveled within the heliosphere, the vast magnetic bubble inflated by the solar wind. Then, in 2012, it crossed the heliopause, the invisible frontier where the solar wind finally yields to the galaxy. This wasn't a wall. It was a thinning breath of our star finally giving up, a transition from the familiar gusts of our sun to the ancient, whisper-thin medium between the stars. The particle density changed. The magnetic field shifted. Voyager had entered a new realm. Out here, Voyager drifts at about 17 kilometers per second, roughly 3.5 astronomical units per year. That's fast enough to circle the Earth in under 40 minutes, but in the galactic expanse, it's a crawl. Every year, another 3.5 Earth-Sun gaps are added to the odometer. The distance is now so great we measure its journey in light hours. A command sent from Earth takes nearly a full day to arrive. So, how far can it travel before it dies? The question has two answers. There is the death of its voice and the death of its body. For a spacecraft, life means power and a whisper home. Voyager's heart is not a solar panel. Sunlight is far too faint. Instead, it carries 3 radioisotope thermoelectric generators, or RTGs. Inside, pellets of plutonium-238 naturally decay, releasing a steady, reliable heat. This heat radiates across thermocouples, generating a constant flow of electricity. At launch, they produced 470 watts. But like all such power sources, they are steady, fading campfires that lose a few watts each year as the plutonium decays. To save power, engineers have been performing a slow, careful triage for decades. They've been turning instruments off one by one, shutting down heaters for components that can survive the deep cold, squeezing every last electron like oxygen in a diving bell. The science instruments that studied Jupiter and Saturn fell silent long ago. Now it's a battle to keep just the essential systems alive: the computer, the attitude control, and most importantly, the 23-watt transmitter. At some point in the late 2020s or into the 2030s, the inevitable will happen. The voltages will sag too far. The remaining power will be insufficient to operate the transmitter. The final whisper from the edge of the solar system will cease. It won't be with a bang, just a final, weakening heartbeat lost in the cosmic hiss. Our connection, our ability to hear its story, will be severed forever. By then, Voyager 1 will be roughly 170 to 200 astronomical units from the Sun, so far that sunlight is a thin memory, a star barely brighter than others in the sky. Our giant radio dishes on Earth, straining to listen, will hear only silence. The final data packets, traveling for more than a day, will have arrived, and the stream of bits per second will fall to zero. That is the first death. The death of communication. That's the death we can measure, the last signal. But Voyager itself? It doesn't stop. With no fuel burned to cruise. The physics is simple. Momentum. It will coast for thousands of years, a dead but intact relic. In about 300 years, it will enter the inner edge of the Oort cloud, the theoretical sphere of icy bodies that marks the true gravitational boundary of our solar system. It will spend tens of thousands of years traversing this sparse, dark realm. In about 40,000 years, it will pass within roughly 1.6 light-years of a star called Gliese 445. This isn't a rendezvous. It's a silent, passing nod in the dark. It won't visit, won't break, won't blink. The star's gravity will be too weak at that distance to capture it. Voyager will just keep going, its trajectory barely nudged, continuing its lonely pilgrimage into the galaxy. Galactic tides will eventually capture the little craft, pulling it into a lazy 225 million-year orbit around the center of the Milky Way. It will circle our galaxy again and again, and bolted to its side is its most precious cargo, the Golden Record. Our message in a bottle. It contains sounds and images of Earth, music from different cultures, and greetings in 55 languages. Its gold-plated copper surface is designed to last for 1 billion years or more, a time capsule that will outlive every mountain and ocean on Earth. So, how far can Voyager 1 travel before it dies? For us, it ends when we can no longer hear it, when it becomes a ghost in our memory. But for the universe, Voyager does not die. It endures, mute, tireless, forever falling through the dark. The odds of a direct collision with another star or planet are infinitesimally small. It will likely survive for eons, eroded only by the occasional micrometeoroid and the slow sandblasting of interstellar dust. A human idea flung into the night, and the night keeps it.